This is SpaceTime Series 20, Episode 56, coming up on SpaceTime. Up close and personal with Jupiter's Great Red Spot. Astronomers probing the swirling halo of a spectacular starburst galaxy. And more evidence supporting the likely existence of Planet 9 in outer space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
The closest ever images taken of Jupiter's majestic Great Red Spot are revealing the giant storm to be a tangle of dark vein-like clouds weaving their way through a massive crimson oval. The imager aboard NASA's Juno mission snapped pictures of the most iconic feature of the solar system's largest planetary inhabitant during its July 10 flyby. The images were taken at an altitude of just 9,000 kilometres above the storm's swirling magenta cloud tops. Juno's principal investigator, Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says scientists have been observing, wondering and theorizing about Jupiter's Great Red Spot for hundreds of years. Now they have the best pictures ever taken of this iconic storm. Bolton says it'll take the researchers some time to analyze all the data from JunoCam, as well as the spacecraft's science instruments, to shed some new light on the past, present and future of the Great Red Spot. The images were downloaded from the spacecraft's memory the day after the historic flyby. They were then placed on the mission's JunoCam website, where citizen scientists were invited to take the raw images and process them for use on the official NASA press release. The Great Red Spot is a massive high-pressure anticyclone, which has been raging across the Jovian southern hemisphere for at least the last 350 years, and possibly centuries longer. Observations indicate the iconic storm is shrinking. However, exactly how much longer it will last is an open question. Back in the late 1800s, the Great Red Spot was some 41,000 kilometres across. Now, that's more than 3 times as wide as the Earth. But as of April 3, 2017, it had dropped to just 16,350 kilometres in diameter. Mind you, that's still some 1.3 times the width of the Earth. Juno's Great Red Spot encounter comes as the spacecraft celebrates the first anniversary of its arrival at Jupiter. Juno was launched on an Atlas V rocket on August 5, 2011 from the Cape Canaveral Air Force Base in Florida, achieving Jovian orbit insertion on July 5, 2016. Since its arrival at Jupiter, Juno's now travelled more than 114.5 million kilometres in orbit around the gas giant. Of course, each new orbit brings the spacecraft a little bit closer to the heart of Jupiter's deadly radiation belts. But so far, the probe's weathered the storm of electrons surrounding Jupiter better than mission managers could ever have hoped. The 3,526 kilogram spacecraft is undertaking a series of 37 extremely highly elliptical polar orbits around Jupiter. Each of these hyperbolic orbits takes some 53.5 Earth days. The unusual orbits are designed to swing the probe deep down to within 3,400 kilometres of the swirling Jovian cloud tops, while at the same time avoiding as much of the planet's crippling radiation belts for as long as possible. The Juno mission is studying the planet's structure and gravitational fields, its magnetic fields and auroral activity, and its atmosphere, chemical composition, cloud structure, wind and weather patterns. This data should allow scientists to better understand Jupiter's origin and evolution, and hence the evolution of the early solar system. It should also give them a better understanding of Jupiter's long-theorized mysterious metallic hydrogen mantle. You see, little's known about the properties of metallic hydrogen. You can think of it as a sort of degenerate matter. It's also a phase of hydrogen which behaves very much like an electrical conductor. At high pressure and temperatures, metallic hydrogen may exist as a liquid rather than a solid. And researchers think it's probably present in large amounts in the hot gravitationally compressed interiors of the gas giants Jupiter and Saturn. In January 2017, scientists at Harvard University reported the first ever creation of metallic hydrogen in a laboratory. They claim to have achieved this by using a diamond anvil cell at a pressure of around 495 gigapascals. That equates to no less than 71,800,000 pounds per square inch. However, several other research teams in the field are now seriously questioning that claim. Juno's early science results are portraying Jupiter as a wild, turbulent world with an intriguingly complex interior structure, energetic polar aurora, and huge polar cyclones, each the size of the Earth. If Jupiter were much bigger, it would be a substellar brown dwarf. As it is, Jupiter generates far more energy than it receives from the Sun. Because it's the solar system's largest planet, Jupiter is often referred to as the king of planets. In fact, it's bigger than the combined mass of all the other planets and everything else in the solar system other than the Sun. Jupiter is about 5 times further away from the Sun than the Earth, with an average orbital distance of 778 million kilometres. At that distance, a Jovian year takes approximately 11.86 Earth years. In spite of the gas giant's diameter of 142,984 kilometres, it rotates extremely rapidly, with the Jovian day taking just 10 hours. Juno's next close flyby of Jupiter will occur on September the 1st. NASA's Director of Planetary Science, Jim Green, describes the highly anticipated images of Jupiter's Great Red Spot as the perfect storm of art and science. With data from Voyager, Galileo, New Horizons, Hubble and now Juno, Green says scientists have a better understanding of the composition and evolution of this iconic feature than ever before. And if you want to check out the newest images of the Great Red Spot, just go to the SpaceTime website at spacetimewithstuartgary.tumblr.com. And of course that's Tumblr without the E. And this is SpaceTime. I'm Stuart Gary. Astronomers have probed a nearby starburst galaxy, which is making stars some 5 times faster than the Milky Way. The study focused on the Sculptor Galaxy NGC 253, which is 11.5 billion light-years from Earth and undergoing a period of intense star formation, hence its starburst galaxy classification. Astronomers used a radio telescope in outback Western Australia to observe the Sculptor Galaxy's halo in unprecedented detail. The Sculptor Galaxy, or NGC 253, is sometimes called the silver dollar or silver coin galaxy because of its shiny bright appearance. In reality, it's an intermediate spiral located in the southern constellation of Sculptor. Now, intermediate spirals have shapes that fill the gap between spiral galaxies such as the Milky Way and unbarred spirals like the Whirlpool Galaxy. The Sculptor Galaxy is over 70,000 light-years across and is the largest member of the Sculptor group of galaxies, the nearest galactic group to our own local group of galaxies, which includes the Milky Way. It's also one of the brightest galaxies in our sky, surpassed only by the M31 galaxy in Andromeda, as well as the Sombrero Galaxy and some of the other nearby companion galaxies in our local group. The Sculptor Galaxy is also a major source of high-energy X-rays and gamma rays, likely due to an active supermassive black hole at its core, at least 5 million times the mass of our Sun. In addition to its spectacular spiral dust lanes, tendrils of dust appear to be rising from the galactic disk, laced with young star clusters and star-forming regions. The galaxy's high content of molecular gas and dust clouds, which gives the galaxy its dusty appearance, is also the reason why it's undergoing such frantic starburst activity. The halo originates from galactic fountains, caused by star formation in the disk and a superwind coming from the galactic core. Having a starburst galaxy so relatively nearby allows astronomers to undertake detailed observations of both galactic processes and stellar evolution, providing a means to test various theories. The Sculptor Galaxy's enormous halo of gas, dust and stars hadn't previously been observed at radio frequencies below 300 MHz. The new studies using data from the Galactic and Extragalactic All-Sky Murchison Wide Field Array, or GLEAM survey, which was undertaken by the Murchison Wide Field Array Radio Telescope in outback Western Australia. The GLEAM surveys allowed scientists to see the galaxy for the first time in unprecedented sensitivity at low radio frequencies. In fact, astronomers were surprised to see just how easily the Murchison Wide Field Array was able to detect the galaxy's diffuse halo. And this allowed them to see the Sculptor in its full glory with just an hour of observing time as the galaxy passed overhead. A report in the Astrophysical Journal claims astronomers were able to detect radio emissions from electron spiraling in magnetic fields being accelerated by supernova explosions and absorption by dense electron-ion plasma clouds. One of the study's authors, Professor Lister Stavelli-Smith from the University of Western Australia's International Centre for Radio Astronomy and Research, and Castro, the ARC Centre for Excellence for All-Sky Astrophysics, describes the observations as absolutely fascinating. The Murchison Wide Field Array is one of the precursor observatories for the development of what will be the world's largest radio telescope, the Square Kilometre Array, or SKA, which is being built in Western Australia and South Africa over the next decade. Once operational, the SKA will be capable of surveying unprecedentedly huge regions of the sky, in the process discovering many new star-forming galaxies. However, Stavelli-Smith says that before astronomers are ready to conduct a large-scale survey of star-forming and starburst galaxies with the SKA, they first need to know as much as possible about these galaxies and what triggers their extreme rates of star formation. By getting to the bottom of what's causing the Sculptor Galaxy to produce so many stars, Stavelli-Smith and colleagues will be able to better understand how other galaxies across the universe form, grow and evolve over time.
The Sculptor Galaxy is a very famous nearby galaxy. We call it NGC 253. Most particularly well known for its central starburst. So when we look at the galaxy, not in optical light, but in X-rays and in optical emission lines, it really glows. And that seems to be a result of intense bursts of star formation going on in its nucleus.
Now, in our own Milky Way, we make a solar mass star maybe once an Earth year. How does that compare to what's happening with the Sculptor Galaxy?
So the Sculptor Galaxy is forming stars at a very high rate, and we believe that rate corresponds to about 5 solar masses, 5 times the mass of the Sun, produced in the form of new stars, usually quite massive stars, which is considerably greater than our own Milky Way galaxy.
And what you guys have been doing is looking at it with the new eyes of the Murchison Wide Field Array telescope.
That's right. The MWA is a new telescope. It's been operating for about 3 or 4 years now in Western Australia in the outback. And because it's located in such a pristine, low-noise environment, we've been able to look at this galaxy. In fact, we've been looking at the whole sky at much lower frequencies than has ever really been possible before. And it allowed us to probe not just the inner parts of the galaxy, but have a look at the outer parts of the galaxy too, the halo that surrounds the galaxy.
And what have you seen?
What we saw at these low radio frequencies, these long wavelengths, was a very extensive halo around the Sculptor Galaxy. That halo was about 20,000 light years in height, more extensive than we'd previously thought. And it seems to be the result of the superwind, the massive amount of energy being pumped into the halo of this galaxy by the central starburst. And we believe the radio emission we see results from very high energy particles, what we call cosmic rays, interacting with relatively strong, astrophysically speaking, magnetic fields. And the radiation that results is being picked up by a radio telescope at quite large distances from the plane of the galaxy.
There's a whole bunch of stars that are being born. As they begin shining, they emit copious amounts of ultraviolet and other radiation, and that radiation, as well as starting to clear out their own stellar systems, is so powerful it's pushing material up into, it's expanding the halo.
Yes, and we see this in other wavelengths too. Sculptor Galaxy has got some very well-known X-ray observations which show the effect of this energy going into the halo very clearly. Optical emission line maps images also show the same thing. And, the overall scenario is that the energy from the central starburst, not just ionizing radiation, but also mechanical energy, just the sheer pressure that's injected into the halo by the stellar wind, by the superwind, that pressure, the ionization, combines together to create this huge outflow, and this outflow is responsible for electrons being accelerated and interacting with magnetic fields, giving rise to the radio emission.
And that's what you're seeing. The Murchison Wide Field Array is doing an incredible job. It's only been going for a few years, but you've already been able to survey about 90% of the sky?
Yeah, in fact, we've been able to survey all of the sky. We can, more or less all of the sky we can see from its position in the southern hemisphere. And in fact, we've been able to go into the northern hemisphere. So all in all, the so-called GLEAM survey has surveyed 3/4 of the whole sky, north and south. So we've surveyed the whole of the southern hemisphere and half of the northern hemisphere, which has been fantastic.
And this is one of the projects that are sort of acting as a lead into the Square Kilometre Array project, which will be the world's largest radio telescope.
Yes, the MWA is one of 3 SKA precursors, 2 of which are in Australia, the other one being the ASCAP, which is a higher frequency array. The MWA was the first operational precursor. It's been going for a few years and is certainly has been delivering very high quality signs in a new frequency range for the last few years. So it's been tremendous seeing the new signs coming out of the MWA, and we greatly look forward to even more better signs, higher resolution coming out of the SK when it gets constructed in due course.
That's Professor Lister Stavelli-Smith from the University of Western Australia. And you're listening to SpaceTime I'm Stuart Gary. If you want more space time, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. There's new evidence supporting the likely existence of a ninth planet in our solar system. Hypotheses for a potential planet 9 in the dark outer reaches of our solar system first came to light in 2014, following the discovery of unusual orbits for several trans-Neptunian objects in the Kuiper Belt by Scott Shepard from the Carnegie Institute and Chadwick Trujillo from the University of North Arizona. Then in 2016, Mike Brown and Konstantin Batygin from the California Institute of Technology calculated that the strange orbits detected for these distant objects were likely caused by the gravitational perturbations of a large body, about 4 times the size and 10 times the mass of the Earth, circling the Sun on a highly elongated and inclined orbit at a distance of around 700 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres or 8.3 light minutes. Trans-Neptunian objects are frozen worlds, comets and other icy debris which circle the Sun beyond the orbit of Neptune. The Kuiper Belt is a subset of trans-Neptunian objects. It contains those objects orbiting the Sun in a disk between Neptune's orbit, which is about 30 astronomical units from the Sun, and a region known as the Kuiper Cliff, about 55 astronomical units out, which is a point where the number of Kuiper Belt objects appears to suddenly drop off dramatically. Beyond the Kuiper Belt is what's known as the scattered disk, which contains objects in highly irregular elliptical orbits with extreme inclinations. Still further out is the theoretical Oort cloud, really a generic catch-all term used to include any objects in interstellar space which are gravitationally bound to the Sun but beyond the Sun's heliosphere, between about, say, 50,000 and 200,000 astronomical units, which equates to about 0.8 and 3.2 light years. The Oort cloud is divided into 2 regions, a disk-shaped inner Oort cloud, also known as the Hills cloud, and the more spherical outer Oort cloud. Mike Brown's involvement in the study is highly ironic. That's because it was his work which is partially responsible for the 2006 decision by the International Astronomical Union to demote Pluto from its former position as the solar system's 9th planet down to a new category of dwarf planets. In fact, Brown's Twitter handle even describes him as the man who killed Pluto. However, things started to look a little bit less certain for Planet 9 supporters last year, when scientists from the Canadian-French-Hawaiian project OSIS detected biases in their own observations of the orbits of trans-Neptunian objects, which had been systematically directed towards the same regions of the sky. They then suggested that the Caltech team could be experiencing the same issues. Now, if correct, it means a new Planet 9 wouldn't be needed to explain the observations, as these would then be compatible with any random distribution of orbits. So I guess instead of a Planet 9, it would mean a Planet None. And that's where 2 astronomers from the Complutense University of Madrid come in. They've applied a new technique, less exposed to observational bias, in order to study extreme trans-Neptunian objects located at distances greater than 150 astronomical units. The Spanish team analysed the distances from these objects' nodes to the Sun, reporting in the monthly notices of the Royal Astronomical Society letters that their new results do appear to support the possible existence of a 9th planet beyond Pluto between about 300 and 400 astronomical units from the Sun. By the way, nodes are the 2 points at which the orbit of a celestial body crosses the plane of the solar system known as the ecliptic, which is made by the orbit of the Earth and the other planets around the Sun. These nodes, therefore, are the precise points where the probability of interacting with other objects is the largest. And therefore at these points, extreme trans-Neptunian objects are likely to experience a drastic change in their orbits, possibly even a collision. One of the study's authors, Carlos de la Fuente Marcos, says if there's nothing to perturb them, the nodes of these extreme trans-Neptunian objects should be uniformly distributed, as there's nothing there for them to avoid. On the other hand, if there are one or more perturbers, 2 situations could arise. One possibility is that the extreme trans-Neptunian objects remain stable, and in this case they tend to have their nodes away from the path of possible perturbers. On the other hand, if they're unstable, they behave in exactly the same way as comets interact with Jupiter, by tending to have one of their nodes close to the orbit of any hypothetical perturber. Using calculations and data mining, the Spanish astronomers have found that the nodes of the 28 extreme trans-Neptunian objects they analysed, as well as 24 extreme centaurs with average distances from the Sun more than 150 astronomical units, are clustered in certain range distances from the Sun. Centaurs are minor planets with a semi-major axis between those of the outer planets. They have unstable orbits because they cross or have crossed the orbits of one or more of the large giant planets: Jupiter, Saturn, Uranus and Neptune. As a result, almost all their orbits have dynamic lifetimes of only a few million years. Centaurs typically behave with characteristics of both asteroids and comets. It's estimated there are probably about 44,000 centaurs in the solar system, with diameters larger than a kilometre. Getting back to the study, the Spanish authors also found a correlation where none should exist between the positions of the nodes and the orbital inclination. Inclination refers to how far above or below the ecliptic an orbit's tilted, and it's one of the parameters which defines the orientation of the orbits of these icy objects in space. The authors say that assuming the extreme trans-Neptunian objects are dynamically similar to the comets that interact with Jupiter, the results do appear to indicate the presence of a planet that's actively interacting with them, but interestingly, probably at a range of around 300 to 400 astronomical units rather than the originally proposed 700. The important thing about these calculations is that they can't be attributed to any observational bias as suggested by the Canadian-French-Hawaiian team. Until now, studies that challenged the existence of Planet 9 using the data available for these trans-Neptunian objects argued that there were systematic errors linked to the orientations of the orbits, defined by three angles, due to the way in which the observations had been made. However, the nodal distances mainly depend on the size and shape of the orbit, parameters relatively free of observational bias. Meanwhile, a separate team of astronomers have detected another potential planet-sized trans-Neptunian object. This potential planet 10, dare we say planet X in Roman numerals, was also inferred by its gravitational effects on the orbits of trans-Neptunian objects in the Kuiper belt. If it exists, planet X would be much closer than planet 9 from outer space. Hollywood sci-fi does have a lot to answer for. Astronomers Catherine Volk and Renu Malhotra from the University of Arizona have found that the plane on which these recently detected trans-Neptunian objects orbit the Sun is slightly warped, a fact that could be explained if there was a perturber, say the size of Mars, at a distance of about 60 astronomical units from the Sun. Mind you, given the current definition of a planet, this other mysterious object may not be a true planet. Bye-bye Planet X. You see, even if it was as large as Mars, or even larger, similar in size, say, to the Earth, it would still be surrounded by lots of other huge asteroids and dwarf planets, meaning it wouldn't have cleared out its orbit, one of the key definitions of a planet based on the 2006 International Astronomical Union meeting. Whatever you call it, the Spanish team are convinced that Volk and Malhotra's work has found solid evidence for the presence of a massive body beyond the Kuiper Cliff. I'm Stuart Gary, you're listening to SpaceTime. Russia has launched the Soyuz rocket carrying a staggering 73 satellites into orbit. The Soyuz 21A rocket blasted off from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. It took a complicated series of engine burns over some 8.5 hours for the Soyuz frigate upper stage to deliver its large payload into their correct low Earth polar orbits. The mission's primary payload was the Russian Federal Space Agency Roscosmos Canopus 5-1K imaging satellite. The 473-kilogram probe is equipped with multispectral, infrared and panchromatic imaging systems designed to provide wide-angle surface imagery from a 510-kilometre-high sun-synchronous orbit. Canopus 5-1K is the second of a constellation of at least 6 remote sensing satellites. The 72 secondary payloads on the launch included no less than 62 American CubeSats. 48 of these were 3-unit CubeSats for Planet Labs, which will join the company's growing constellation of CubeSats designed for commercial Earth imaging with a 3-metre resolution. A further 8 3-unit CubeSats were deployed for Spire Global's own growing constellation of Lemur 2 satellites. Each Lemur 2 is equipped with 2 payloads, one relaying automatic identification system signals from ships at sea, and the other monitoring how GPS satellite signals are affected as they pass through the atmosphere in order to estimate atmospheric temperature, pressure and humidity. The last of the 3-unit CubeSats in the payload was known as Nano Ace, a demonstrator for the new Endeavour series CubeSat platform, acting as a prototype to show off its new orbital attitude control systems. It's also carrying both infrared and visible light imaging payloads. The Soyuz was also carrying 3 larger 6-unit CubeSats deployed for geo-optics as part of its own constellation. Like the smaller Lima 2 CubeSats, these also use GPS to infer atmospheric conditions, but as well as GPS, they can also monitor signals from Europe's new Galileo navigation system satellites as well. The final US payload aboard the flight were 2 Corvus 6-unit CubeSats, each carrying a multispectral medium-resolution area survey imaging payload for AstroDigital as part of what will eventually be a 30-satellite constellation. The 10 remaining satellites included 4 Russian Roscosmos CubeSat demonstrators. These included 2 6-unit and 2 3-unit CubeSats carrying a range of payloads. The 6-unit CubeSats each carried imaging payloads with a 20-metre resolution. One of the 3-unit CubeSats was designed to deploy a highly reflective 4-square-metre tetrahedral structure designed to help speed up orbital decay. The thing's large enough and bright enough to be clearly observable from the ground. Undoubtedly yet a new source of UFO claims. The other 3-unit Roscosmos CubeSat is testing new Russian CubeSat technology. The remaining satellites included a joint Russian-Ecuadorian single-unit CubeSat designed to study molecular gas and dust clouds, as well as high-speed data transmission. Also on the manifest was Germany's 140-kilogram flying laptop demonstrator spacecraft, which uses a multispectral imaging camera system for Earth observation, star trackers to search for near-Earth objects, or NEOs, and an automatic identification system receiver to track shipping. Another German satellite in the payload was the 18-kilogram TechnoSat, which is testing a new satellite bus for eventual use on a new spacecraft slated for launch next year. The Soyuz was also carrying a new 40-kilogram Japanese weather satellite, the WinnieSat-1R, which will monitor weather conditions over Antarctic shipping lanes using a combination of lasers, visible light and infrared sensors to monitor the atmosphere and carbon dioxide levels. Finally, there's Norway's NorSat-1 and NorSat-2 spacecraft built by the University of Toronto in Canada for the Norwegian National Space Agency. NorSat-1's equipped with a Langmuir probe, a compact, lightweight absolute radiometer, and an AIS receiver. NorSat-2 also carries an AIS receiver, together with a VHS data exchange system to improve ship-to-shore high bandwidth communications. The mission marked the 8th Soyuz launch this year and the 9th Russian mission so far for 2017. I'm Stuart Gary. You're listening to SpaceTime. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, your favourite podcast download provider, or direct from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., around the world on TuneIn Radio, and as part of Virgin Australia's in-flight entertainment. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and other things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, and on Facebook just go to www.facebook.com/Spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. Subscribe at iTunes, Stitcher, Pocket Casts or Audio Boom. This has been another quality podcast production from Bytes.com.